Okay, so we're going to go ahead and begin. We're still in 1.1, and we're still looking at equations. We're now going to learn how to use some of the formulas. And if you need a formula for this course, you'll find them in the back cover of your textbook for the most part. Or otherwise, it will tell you what formula to use. So we're going to look at how to convert from Celsius to Fahrenheit. So I'm going to give you two formulas, and I'm going to have you convert. So here's our two formulas. The formula for Celsius is C equals 5/9 times F minus 32. Our other formula is F equals 9/5 C plus 32. So we're going to use either one or the other. So I can give you a number in one system, and we can convert to the other. So I can give you a Celsius number. You can convert that to Fahrenheit or vice versa. And we're going to round to the nearest tenth. So we're going to convert and round to the nearest tenth. So let's say I give you the one in your homework is question 6. I'm going to do one similar to it. So let's say I give you a Celsius temperature of 3. And I want you to convert that to Fahrenheit. So we want to find our F value. And what does F equal? Well, F equals 9/5 C plus 32. So we're going to plug our value in for C. We're going to work it out. And how far do we round? We round to the nearest tenth, and tenth is one place. So let's plug in our 3. And if you want, you can write that as a 3/1. And then we'll have our plus 32. So we've got 9 times 3. 9 times 3 is 27/5 plus 32. Now we are rounding to the nearest tenth, so that's one decimal place. And that's still our F there. So that means when we divide through, we've got 27. Divide that by 5. That's 5.4 plus 32. Adding them together, we get our answer in terms of Fahrenheit, which is then 37.4 degrees. There's one just like this in your homework on question 6. It's just that in your homework, they give you the Fahrenheit temperature, and we have to convert to the Celsius. But they've got both formulas listed. So if you look here on question 6 in your homework, you've got both formulas here. They give you a Fahrenheit temperature of 1, so you're going to have to use that first formula, convert that to Celsius, and round to the nearest tenth. Another one that we're going to look at is simple interest. And simple interest is this. For simple interest, I equals P R T. So that is going to be our formula for simple interest. And what do the variables mean? Well, when we look at this, our simple interest, I is going to be your interest. R is the rate as a decimal. Here's where students make a mistake. T is time in years. So you have to make sure If it's in months, we're going to have to convert it to years. So make sure if it's 8 months, we would take that 8 and we would divide it by 12 because that's going to convert it to years. We have to make sure time is in years, and P is the principal or the starting amount. So this is our formula, and we're going to be using this formula to solve this application. So here's our question. If $800 is put in a CD, that pays 3% for, let's say, how about 18 months? What is the interest earned and total amount? So we're going to first find our interest, and then we'll add the interest to that $800, and that's going to tell us how much money we're going to have. So let's look at our pieces here. I always like to write up our formula. So we're going to use the formula I equals PRT. I we don't know, so that's our unknown. Our P is how much money we start with. Well, how much money do we put in that CD? Well, we put $800 in that CD. Our interest rate, R, as a decimal is 3%. So that would be 0.03. Here's where students make a mistake. What is our time? Our time is not 18 because we did not put it in for 18 years, did we? What did we put it in for? 18 months. So we've got 18 over 12. And we might be able to reduce that down a bit because 18 and 12, they both have a 2 in common. So let's go ahead and reduce this down as far as we can. Actually, there's a 6 in common, so we could reduce this down by a factor of 6. So 18 over 3, or sorry, 18 over 6 is 3. And 12 over 6 is 2. So our time is 3/2 or 1.5 years. We always want to keep the fractions until the very, very end. That way you don't make a mistake. So do not round until the very, very end. If you round too early, your answer might be off a bit. Now, 3/2 is 1.5, so that one won't matter. But if it would have been 1/3 and you rounded too early, it would be off by a couple of cents. So we want to keep those fractions until the very, very end. So let's go ahead now and find our interest. So I equals now 800 times 0.03 times 3 over 2. We're simply going to multiply the numerators together, so all the numbers on the top. Then we'll divide by the 2 at the end. So 800 times 0.03 times 3, that makes it 72. And 72 divided by 2 comes out to be an even $36. So we made now $36. Double check and make sure we do everything right here. Yep, everything looks right. Okay, so we made $36. So my interest is $36, and my total amount that I have at the end is going to be $800. And so that's what we've got there. We've got our interest to be $36 and our total amount to be $836. Is everyone okay with how I did that? Now we're going to round to the nearest cent. That one we didn't have to round at all, but in your homework you may have to round it. And so we round at the very end, round to the nearest cent, which is 2 places. Another type of problem that I want us to look at, just to make sure we have these down, is how we handle the x in the denominator of a fraction. So let's try and determine how we would solve this. How would we solve 3/4 x minus 5 over 2x equals 7? Now this one's a little bit different. Why is this one different? Well, in this case with these fractions, our second fraction right here is 5 over 2. It has an x down below. So we need to learn how to clear out that x in all the fractions. Well, when we look at this, what's our least common denominator again? I made this one easy. The least common denominator of 2 and 4 is going to be what? 4, right? Because 4 goes into itself one time, and 4 goes into 2 twice. Instead of just multiplying it by 4, we're going to multiply it all by 4x. That way, we get rid of that x down below. So we're going to go ahead and distribute that 4x through. Again, we're using a 4x because there's an x down below. That's going to clear out all the fractions and leave us with something that we can easily solve. So let's go ahead and do that. Okay, 4 divided by 4, they cancel. So that's 1. 1 times 3 is 3. We got the x with it. So the first piece is 3x. The second one, what's going to happen here? Well, 4 divided by 2 is 2. What about the x's? One's on top, one's down below. They cancel. So that leaves you with a 2. And 2 times the negative 5 on top makes it a negative 10. So the x is canceled there. On the right-hand side, what do we have? We have 4 times 7. So 4 times 7, that's a 28. The x will not cancel, so we're left then with a 28x. Is everyone okay with how I cleared that out? Now, why did I use that 4x? Because there was an x down below. Okay, that got rid of that one there. This one, there was no x to cancel out, so it just came down with it. Same thing with the 7. 4 times 7 is 28. No x is canceled, so it came down. Now we can finish it. So I'm going to move that 3x over with subtraction. And that leaves me then with a minus 10 equals, now it looks like, a 24x. Or not 24, sorry, it'd be 25. Yep, my mistake there. There'll be a 25x there. 28 minus 3 makes it, 25. We need to finish it, so how do we finish it? Divide both sides by that 25. And then we're going to reduce. So what we've got before we reduce is we've got minus 10 over 25. But minus 10 over 25, well, that reduces down to be a minus 2, what, 2 fifths, doesn't it? Okay, so that's going to be our final finished answer. Is everyone okay with how I did that? And if I make a mistake, anything like that, or add something wrong, just be sure and tell me. Because sometimes I make mistakes, and I'm pretty careful. Once in a while, mistakes happen. So again, let's review what we did. We looked at this problem. We saw that x was down below. So I know I need an x on top to clear it out. The least common denominator, 2 and 4, is 4. So I used a 4x here. 4 divided by 4 is 1, times 3 makes it a 3. The x comes along with it. Next, 4 divided by 2 is 2, times 5 makes it 10. The negative comes down, the x's cancel. Last piece, 4 times 7. 4 times 7 is a 28. X didn't cancel, so it stays there. I move the 3x over with subtraction. And 28 minus 3 makes it then a 25. Divide by your 25 to make those go away. And I put my x on the left-hand side. And that's minus 10 over 25. And that then reduces down to what? 2/5. Is everyone okay with how I did that? So there's one just like that in your homework because it looks very, very similar to question 17. You look at 17, so it looks very, very similar to what we just did. You can reduce that down, clear out your fractions, and solve it. That now finishes up 1-1. So we're now going to move on and look at 1-2. And 1-2 is applications. These are applications that you probably have seen before. It might have been a while, so we're going to spend some time learning how to set these up. So we'll do a couple of examples of each type. We've got mixture problems where we mix chemicals together at different concentrations. We've got distance problems. We have interest problems. And then we also have geometric figures. So we're going to begin with some of the geometric figures. So I'll try to do 1, maybe 2 of each of these. And I'm going to be pulling these from our textbook. So an easy one to start with, I think, is question 15. And this is on page 119. Now, we can always look up formulas if we need them. But when we talk about perimeter, it doesn't matter what the figure is. Perimeter means you sum up all the sides. So we can look that formula up in the back cover, or we can just remember that perimeter, irregardless of the figure, means you add up all the sides. So we're going to be looking at 15. And we're looking at a triangular plot of land. So we're going to read it. We'll draw a picture if we need to, use our formula, solve it, and then make sure we answer the question. We don't label with units until the very end. If we start putting units early in the problem, then it gets too cumbersome and confusing. So we never label with our units like feet or yards or miles until the very, very end. So we're going to look here again at 15. Let's read it, see what we've got, draw a diagram if we need to, solve it. So 15 says the perimeter of a triangular plot of land is 2,400 feet. The longest side is 200 feet less than twice the shortest. The middle side is 200 feet less than the longest side. Find the lengths of the 3 sides of this triangular plot. So when we talk about a triangle, it's got 3 different sides, because it doesn't say it's equilateral, so we assume they're all different. And we have a short side, a middle side, and we have the longest side. And just so we know, this is page 119, question number 15. So just so you have that as a reference. We've read the problem once already. We know we're working with a triangle. We could draw a picture, but we may not need to. We know in a triangle we have a short side, a middle side, and a longest side. Now what I like to do is label it with words first. Then we put our variable in, and then we can get our equation. So the perimeter of this plot of land is 2,400. So we'll keep that over to the side over here. So we'll just come back to that here in a moment. And if you need to, you can always divide your paper into sections if it helps. So we've got a short, a middle, and a longest side. We know our perimeter is 2,400 feet. We'll label this here in a moment. The longest side is 200 feet less than twice the shortest. So my longest side is 2 times the short side minus 200, right? And we'll plug in the variables in a moment. I always like to start with words first, then variables. So that's our longest side. Longest side, 200 feet less than twice the shortest. The middle side is 200 feet less than the longest. So the middle side is the longest minus 200. And which one do we not know about? We don't know anything about the short side. So we're going to label that short side X. Now let's try and get it all in terms of the variable X. So we've got our short side, which is X. The middle side we'll come back to here in a moment. And what about the longest side? What's the longest side going to be? It's going to be 2x minus what? 200, right? The middle one we haven't talked about yet because the middle one has the longest side in it. So the middle one is going to be the longest side, which is 2x minus 200 minus an additional 200. And so that makes your middle then 2x minus what? 400 total. So there's your middle side. And I'll put a box around each of these so we can see them. Our short side is x, and our longest side is 2x minus 200. Is everyone okay with how I came up with that? Now, what do we know about the perimeter? By definition, the perimeter is the sum of all sides. So that's your definition of the perimeter. Now we can build our equation. So what's our equation look like? Well, our equation is our perimeter equaling 2,400. And we know our perimeter is the short side plus the middle side plus the longest side. And we know the short side is x. We know the middle side, when we worked it out, was 2x minus 400. And then we know our longest side is 2x minus 200. And that still equals now our 2,400. And we should be able to combine like terms and solve it. So let's go ahead and combine our like terms together. See how many x's we have. We have an x, another 2x, and another 2x. That makes it then 5x. And then we've got minus 400 minus 200. Makes it minus 600. Next, we're going to go ahead and move that 600 over with addition. And that then leaves us with 5x equaling 3,000. We'll divide by our 5. And that then I believe should be 600. Now we're not completely done yet because we need to make sure that we answer the question. And the question is, what are the lengths of all the sides? And we need to make sure we put our units on. So we've got our x. So let's go back up and see what we've got. If we go back up and look, we've got our short side, which was x. And we know x is 600. So that means the short side is going to be 600 feet. Then we've got the middle side. And what did we determine the middle side was? 2x minus that 400. That's your middle. And that's then 2 times your 600 minus 400. And that gives you what? 800 of it. Because 2 times 600 is 1200 minus 400. It makes it 800. And that's 800 feet. And then we need our longest side. And what's the longest side? Well, the longest side is 2x minus 200, which is then 2 times your 600 minus 200, which is then 1,000 feet. Always double check and make sure your answer seems right. But what do we know about the perimeter? Perimeter better be all those sides added up, right? So if we add up all these sides, what should we get? If we add up all these sides, we should get that 2,400. So we've got 600, 800, and 1,000. And that gives you your 2,400 total. Right? So we were able to check it, and we got our answers for that particular question. So what's the key takeaway here? Perimeter. What is perimeter? Adding up all the sides. Doesn't matter whether it's a rectangle or like this one, a triangle. Add up all the sides. That gives you the perimeter. So that's a geometric figure. And most students don't struggle too much with those. They struggle more with the distance, mixture, and investment problems. So we're going to try and do 2 of each one. So let's look now on page 120, and we're going to look at a distance problem, and we're going to look at question 22. When we look at distance and driving a car, there's 3 components that go into that. When we drive a car and we go from school to work, what do we have? We have how long does it take us to get there? We've got a time. Okay? We've got a rate of speed, how fast we're going. And then we have how many miles we drove to get there. So rate, time, and distance. Now the rate times the time, that's going to give you your distance. So let's read question 22. We may have to draw vectors. Vectors indicate direction. And on these, they can either add, subtract, or equal each other. So let's read our question. We'll talk about the different vectors, draw our diagram, make our equation, and solve it. So 2 planes leave Los Angeles at the same time. One heads north to San Diego, south to San Diego. The other heads north to San Francisco. San Diego plane flies 50 miles an hour slower than the San Francisco plane. In a half hour, the planes are 275 miles apart, and we want to know their speeds. When we look at distance problems, there are 3 possible outcomes, and they work with our vectors. So they can add together. If they go north and south, or east and west like this, or they go towards each other like this, these are all addition. So these are going to be addition. So if your diagram looks like one of these three, then it's addition. If they overlap, it's subtraction. So that would look like that. And that would be like two cars in a race on a racetrack. One's ahead of the other one, and we want to know by how much, we subtract. So if they overlap, we use subtraction. If they're the same, then they equal each other like this. And what would that one be? Well, that would be like going to work and coming back home. It's the same miles, right? It's 10 miles to work, it's 10 miles back home. So they're going to equal each other. So our three outcomes are addition, subtraction, or they could equal each other. So let's now go back to our question. We were talking about two planes that are going to leave LA. So this is our question here. So we'll start here at LA, and we've got one heading north, and we've got one heading south. So move it up so we can see what we've got. So we're going to start here in LA, and we're either going to go north to San Francisco or south to San Diego. So we'll kind of diagram this out as to what we've got. And what do you think this is going to be? Addition, subtraction, or equals? Well, they're going in opposite direction. Do these overlap at all? No. If they do not overlap, then that means it is what? Addition. Now there are three components that go into a distance problem. Rate, time, distance. Normally, for most problems, what we have is we have the rate and the time, and we have to find the distance. So for the San Francisco plane, we've got a rate and we've got a time. And same thing with the San Diego plane, rate and we've got a time. So let's see if we can come up with our components. So one goes north, one goes south, and it says the San Diego plane flies 50 miles an hour slower than the San Francisco plane. So we don't know the San Francisco plane speed. So we're going to call the San Francisco plane x. And we know that the San Diego plane is slower. And it's slower by 50, so it's going to be x minus 50. Now, what about the times? Well, it says they leave at the same time, and they're in the air for a half hour. So it says in a half hour, so that means our time for both of these is going to be a half. Now, how do we build our equation? Well, from what we know about our distance formula, we know our distance equals the rate times the time. That's our main formula. And we're going to look at each of these airplanes independently. And then we're going to talk about our total distance as well. So we're building our distance equation. And let's look at the San Francisco plane. What do we know about the rate and the time? So if we go back up and we look at the San Francisco plane, our rate is x, our time is a half, so our San Francisco plane is going to be a half x. These just go together here. This is what we're looking at right here, the San Francisco plane. What about the San Diego plane? Well, let's look at that. And the San Diego plane is 1/2 for the time, and the rate is x minus 50. Is everyone okay with that? That's just those two put together. I think this is the easiest way to work these out. Now, what does it equal? What's my total distance? And that's given in the problem. Can someone tell me what the total distance would be? Can someone read that problem and tell me what the total distance would be if I read it? Textbook. Okay, well, let's look and see if we can't figure out what this piece is. We want the total distance here. So let's read this last line. It says the San Diego plane flies 50 miles an hour slower than the San Francisco plane in a half hour. The planes are 275 miles apart. So what does that 275 represent? Well, that represents your total distance, right? So that is going here. Does everyone see where I got that piece from? So that's going to be a number, and it's going to tell you the total distance. Now we can quickly and easily solve this. So we've got something that we can work with. We're going to distribute that half through, combine like terms, and solve it. So let's go ahead and distribute that 1/2 through here. And that is then 1/2 x plus 1/2 x. And what's half of 50? Well, half of 50 is 25, right? And what is that going to equal? 275. We don't have to clear out the fractions because we can work with these because we know 1/2 and 1/2 makes it a whole x. So that's going to be your x there. And that 25, well, we'll just add that over to get rid of that. And now we know x. X is going to be 275 plus 25. So x is now 300. Is everyone okay with that? How did I come up with that x? Well, that's a half of an x and another half of an x. That makes it a whole x there. And I move that 25 over with addition. That does not completely answer the question, though, because the question wants you to find the speed of each airplane. And so we need to make sure that we answer the question and label it correctly. So we've got our x. Now, what did x represent? If we go back up and look, let's look at our original diagram again. What did x represent? Well, if we look at our diagram, x represented the speed of the San Francisco plane, right? And what about the San Diego plane? What is it? It's slower by 50. So now we can go ahead and get both of our speeds. So we know the San Francisco plane has a rate of speed of 300, and we're going to label that miles per hour. So that's our speed. So that's your San Francisco plane. And what about the San Diego plane? Well, the San Diego plane is 300 minus 50, and that is then 250 miles an hour. So that's the speed of our San Diego plane. We've got both of our speeds, and we've answered that question. Now, always look and make sure that it makes sense. 300 miles an hour and 250 miles an hour. Did those make sense as to what you would expect an airplane to be traveling at? Yeah, pretty close, right? Makes sense. I mean, if it would have been a car, I would probably say no, because a car is not going to probably be able to travel at 300 miles an hour. But this is an airplane, so always use some common sense when you get your answer and make sure it feels right. If for some reason it doesn't feel right, it's probably not correct. Use some common sense. These look like, okay, they seem like they're legitimate speeds. If I would have said the San Francisco plane is traveling at 8,000 miles an hour, would that make sense at all? No, So I know I probably made a mistake somewhere. Also, if it said, well, the San Francisco plane was traveling at 20 miles an hour, that wouldn't make sense for an airplane either. So use common sense to see, does it make sense? Do I think that answers the question? And if it looks right and it feels right, it probably is. Okay, so let's work through another one of these. This one was an addition one. Now we'll look at one that is a subtraction one. 23 is very similar, and 23 is actually a little bit easier. And we've got a picture for 23. So in question 23, in the Apple Hill Fun Run, Mary runs at 7 miles an hour, Janet runs at 5. If they start at the same time, how long will it be before they are 1.5 miles apart? You always want to write the faster person first. So we'll put that faster one on top. So we've got two people and they're running a race. So they're going the same direction. And this is question 23. So we've got two people and they're running this race, and one is faster than the other. And I generally like to write the faster one first. And the faster one would then be Mary. So Mary has a rate of speed of 7, so 7 miles an hour. Janet is running a little bit slower, and Janet in this case is only running at 5 miles an hour. We need to find our times. Do we know either time? No. Do we know anything about the times? No, but we know they're the same, right? Because they start at the same time. So if Janet runs for 20 minutes, Mary runs for 20. So we don't know what those are, but we do know they're the same. So our times are going to be x. And what else do we know from this problem? Or not x. I think it may actually give us hours. Nope, start at the same time. How long will it be before they are 1.5 miles apart? So what does that 1.5 miles apart mean? That's your total distance. So the total distance is 1.5. And again, you can split your paper up so it's not so confusing. So we've got our diagram. We know our total distance is 1.5. This is not going to be an addition problem. Why not? Why is it going to be subtraction? It's going to be subtraction because these overlap. So whenever they overlap, they subtract from each other. And you always want to write the faster person first. So now we're going to look at our distance. And remember, our distance is the rate times the time. So distance is the rate times the time. And let's look at Mary first. For Mary, we've got a rate and a time. So Mary's rate is 7. Her time is x. So Mary is 7x. Now what about Janet? Well, Janet's a little bit slower. And we know we're going to have to subtract, don't we? Because they're overlapping, they're going to subtract. And Janet has a rate of speed of 5. Time is unknown with an x. And what's my total distance apart here? Well, we already found that in our problem to be what? We found that to be 1.5, didn't we? So now we have our equation. So this one's actually easier to solve than the last one. nothing to it. We're going to put these together. 7 minus 5, well, that makes it a 2x, and that equals 1.5. We're going to divide by 2, and that should give you the x equals 0.75. And we can write it a couple of different ways. 0.75, well, that is 3/4, right? So we could write this as 3/4 of an hour, or we could write this as 45 minutes. So I would take either one of those. So I would take either 3/4 of an hour or the 45 minutes, and I would even take the 0.75 hours. But it's probably going to make more sense with the minutes. The minutes is what you would probably use, so that would probably be your preferred answer. It doesn't specifically tell us though. So I would take the 0.75, I would take the 3/4 of an hour, or I would take the 45 minutes. All of them are the same, so any of them you use is fine. Why don't we go ahead now and take a short break again, and let's meet back here at, how about 8:55 again? So let's take about a 10-minute break, a little over. We'll come back and we'll finish up the lecture for today.